The points A and B have coordinates 4, -2, 3 and 2, 0, -1 respectively. The line L passes through A and has this equation. Find the vector AB. Find the acute angle between AB and the line L, giving your answer to the nearest degree. The point C lies on the line L such that the angle ABC is a right angle. Given that ABCD is a rectangle, find the coordinates of the point D. Okay, here's the question then in summary form. So let's have a little look at it then. I've actually put these coordinates to represent any coordinate on the line: 4 plus lambda, -2 plus 5 lambda, and 3 minus 2 lambda. So we can use that to represent any coordinate on the line. So first of all then, A, part 1. Find AB. So AB as a vector then will be B minus A. So B minus A, 2 minus 4 is -2. 0 minus -2 is 2. -1, take away 3 is -4. So there's the vector AB, part 2. Find the acute angle between the line L and AB. So let's draw a little picture then between the line L. Here's A, and here's the point B then. And we need to find the angle between AB. B has coordinates 2, 0, -1. So let's put that in. 2, 0, -1. A has coordinates 4, -2, 3. Or I'll put it in over here. 4, -2 and 3 out of the way. Okay, so find the acute angle between the line L and the line AB. Okay. So the direction of the line L is this vector here. That's the vector direction of the line, 1, 5, -2. Okay, so part 2 then. So here for part 2. So use the dot product, cosine property, dot product AB, which is this. So -2, 2, -4, that vector, dot the direction of the line, L, which we said was here, 1, 5, -2, 1, 5, -2, will equal the modulus of this vector, 16, square this and square that. 16, square this, 4 and 4 is 24. So the modulus of that vector is root 24. 4, 5, 25 is 30. Cosine of the angle, there's the dot product rule there. So that tells us what cosine alpha is. That will equal, if I do the dot product here, -2 plus 10, so that's 8, plus 8 is 16. So that tells us what cosine alpha is then. It will be 16 over root 24 root 30. So that tells us what alpha is then. Put that in the calculator, shift cos, inverse cos of 16 divided by bracket square root of 24 times the square root of 30. We can write it like that if we wish. Outside the square root, close that bracket, close the bracket for the cosine, shift cos, 53 to the nearest degree, 53 degrees. And that's to the nearest degree. Okay, good. Right, 53 degrees. Okay, so now next part then, part B. C lies on L, so here's the line L, such that ABC is a right angle, so we've got a right angle here at B. And this is the point C. Now C is a point on the line, so parametrically speaking it has these coordinates, doesn't it? So I'm going to put that in for C. 4 plus lambda, -2 plus 5 lambda, and 3 minus 2 lambda. So there's the coordinates of C. And we know they're perpendicular, don't we, to this vector. This vector is perpendicular to this vector. If we put that in, we'll be able to work out the value of the lambda, won't we? So here, this is part B now. So here, so this vector here, AB, which is here, minus 2, 2, minus 4, times this vector here, dot product of this one. Now that would be 4 plus lambda minus 2, wouldn't it, is BC, which is 2 plus lambda. And then we've got minus 2 plus 5 lambda minus 0. And then we've got 3 minus 2 lambda minus 3. No. 3. Let's have a look back up here. Yeah, 3. So 3 minus 2 lambda, take away minus 1 is add 1. So that's 4 minus 2 lambda. And there, look, those two directions are perpendicular, so cosine of the angle is 0. So that equals then minus 2 of these, minus 4 minus 2 lambda. 2 of these, minus 4 plus 10 lambda. And minus 4 of these, minus 16. And plus 8 lambda. So that tells us then minus 2 and 10 and 8 is 16 lambda on this side is equal to, and on the other side, minus 4 minus 8 minus 24. Move that over there to plus 24. So the 16 lambda minus 2 and 10 is 8, plus 8 is 16 lambda. Keep that on this side. I've written it down from right to left. And then minus 4 is minus 8, minus 24. Move that over the other side, plus 24. Lambda's 3 over 2, isn't it? 24 over 16 is none other than 3 over 2. Okay, so this is the vector BC, isn't it? Lambda's 3 over 2. So we need to find the coordinates of D, which if we do the picture, there's D. So we know if we go from O to A, and then we go along this vector here, we'll get down to D, won't we? So OD then, as a vector, is equal to OA, get to A, and then add on this direction here, which is exactly the same as BC here, which equals OA then. What's OA? 4 minus 2, 3, as we said before. 4 minus 2, 3, plus BC. Now BC was this vector here, with lambda equals 3 over 2, so it's 2 plus 1.5 is 3.5. 7 over 2 minus 15 over 2 here, put 3 over 2 in here, 15 over 2 is 7.5, 5.5, that's 11 over 2. And the next one, 2 lots of this is 3, 4 minus 3 is 1. So what have we got? 8 over 2 and 7 over 2 is 15 over 2. 11 over 2 take 4 is 7 over 2. And 3 plus 1 is 4. So D has coordinates then 15 over 2, 7 over 2, and 4. And you can check the algebra more carefully if you need to.